Rewiring a home is a significant undertaking, and understanding the process can help in managing costs and ensuring a safe and effective electrical system. It is possible to string wires from a central point to each outlet and switch location, bypassing traditional attic routing. This method, sometimes referred to as fishing wires, involves maneuvering within the ceiling or wall cavities to run the wires. Be aware that this can be time-consuming. The cost of rewiring a 2100 square foot home depends on several factors, including the size and complexity of the project, the number of outlets and switches, the type of wiring used, and local labor rates. As a general estimate, expect to pay around $5 to $10 per square foot for materials and labor, translating to approximately $10,500 to $21,000 for a 2100 square foot home. To help keep costs down, consider the following. Firstly, provide clear access by removing or relocating any obstacles that could hinder the electrician's work. Secondly, carefully plan your electrical layout, grouping outlets and switches together to minimize wire runs. Thirdly, if comfortable with basic electrical work, consider assisting with tasks such as cutting and stripping wires or installing outlet boxes. Fourthly, obtain multiple quotes from several electricians to compare prices and find the best deal. Fifthly, be willing to negotiate on certain aspects of the project, such as the type of wiring or fixtures, to potentially reduce costs. Here are the general steps to rewire your home. 1. Plan your electrical layout by determining the location of all outlets, switches, and lighting fixtures. 2. Obtain the necessary permits from your local building department. 3. Hire a licensed and experienced electrician for the job. 4. Mark the locations of studs and joists in the ceiling and drill holes for fishing the wires. 5. Pull the wires through the holes using a fish tape or other suitable method. 6. Install outlet and switch boxes, securing them properly to the walls or ceilings. 7. Make the electrical connections connecting the wires to the outlets, switches, and fixtures. 8. Thoroughly test the electrical system to ensure it meets code and is safe to use. Remember these additional tips. Firstly, use high-quality electrical components to ensure durability and reliability. Secondly, install ground fault circuit interrupters, or GFCIs, in the areas where water may be present, such as bathrooms and kitchens. Thirdly, consider installing energy-efficient appliances and lighting to reduce ongoing electricity costs. Let's delve deeper into the electrical wiring aspects. When rewiring, it's crucial to understand the different types of wires and their applications. Non-metallic, or NM cable, also known as Romex, is commonly used for residential wiring. It consists of 2 or more insulated conductors and a grounding wire wrapped in a plastic sheath. NM cable is suitable for dry locations only, and comes in various sizes, such as 14-2, 12-2, and 10-2, where the first number indicates the gauge of the wire and the second number indicates the number of current carrying conductors. The gauge of the wire determines its current carrying capacity, or ampacity. Refer to the National Electrical Code, or NEC Table 310.15b16 to determine the appropriate wire size for a given amperage. For example, 14-gauge copper wire is typically rated for 15 amps, 12-gauge for 20 amps, and 10-gauge for 30 amps. Always consult the NEC for the most up-to-date and accurate information. Another type of wiring is metallic cable, such as armored cable, or AC, and metallic clad cable, or MC. AC cable consists of insulated conductors wrapped in a flexible metal sheath, while MC cable has an additional plastic jacket over the metal sheath. Metallic cables are suitable for both dry and damp locations and offer better protection against physical damage than NM cable. However, they are also more expensive and require special connectors. Conduit is another option for wiring, especially in exposed locations or where extra protection is needed. Conduit is a metal or plastic tube that encloses and protects the wires. The most common types of conduit are rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and flexible metal conduit, or FMC. Each type has its own advantages and disadvantages in terms of cost, ease of installation, and level of protection. When planning your electrical layout, consider the specific requirements of each circuit. General lighting and receptacle circuits are typically wired with 14-2 or 12-2 nm cable, depending on the amperage rating of the circuit breaker. Kitchen and bathroom circuits that serve countertops require 20 amp circuits and should be wired with 12-2 nm cable. Appliance circuits, such as those for refrigerators, dishwashers, and washing machines, may require dedicated circuits with larger wire sizes, such as 10-2 or even larger, depending on the appliance's power consumption. Also, ground fault circuit interrupters, or GFCIs, are essential for protecting against electrical shock in wet locations. GFCIs monitor the current flowing in a circuit and quickly trip the circuit breaker if they detect an imbalance, indicating a potential ground fault. GFCI protection is required for all receptacles in bathrooms, kitchens, garages, and outdoor areas. Arc fault circuit interrupters, or RFCIs, are another important safety device that protects against electrical fires caused by arc faults. Arc faults are unintentional electrical discharges that can occur due to damaged or deteriorated wiring. RFCIs detect these arc faults and trip the circuit breaker to prevent a fire. RFCIs are typically required for all branch circuits that supply outlets or devices in bedrooms, living rooms, and other living areas. When installing outlets and switches, use high-quality devices that are rated for the intended application. Outlets are available in various amperage ratings, such as 15 amp and 20 amp, and should be chosen based on the circuit's amperage rating. Switches are also available in different types, such as single pole, double pole, and three-way, depending on the number of circuits they control. Also, tamper-resistant receptacles, or TRRs, are now required in many jurisdictions, especially in homes with children. TRR have internal shutters that prevent foreign objects from being inserted into the slots, reducing the risk of electrical shock. When making electrical connections, always follow proper wiring techniques. Use wire connectors, such as wire nuts or terminal blocks, to securely join the wires together. Make sure the connections are tight and properly insulated to prevent shorts or ground faults. Also, always ground all metal boxes and devices to provide a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. When working with electrical wiring, always prioritize safety. Turn off the power to the circuit before working on any wires or devices. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a licensed and experienced electrician to do the job. Obtaining permits is a crucial step in the rewiring process. Permits ensure that the work is done in accordance with local building codes and safety regulations. The permit process typically involves submitting a detailed electrical plan to the building department, paying a fee, and scheduling inspections. The inspector will verify that the wiring is installed correctly and meets all applicable codes. Failure to obtain permits can result in fines, delays, and even legal action. When choosing an electrician, look for a licensed and experienced professional who is familiar with local codes and regulations. Ask for references and check their online reviews to get an idea of their reputation and quality of work. Also, get multiple quotes from different electricians to compare prices and services. Make sure the quotes are detailed and include all costs, such as labor, materials, and permits. Negotiate the price if necessary, but be wary of extremely low bids, as they may indicate substandard work or materials. Effective communication with your electrician is essential for a successful rewiring project. Clearly communicate your expectations and requirements, and ask questions if you are unsure about anything. Review the electrical plan together and make sure you both agree on the layout and scope of work. Also, establish a clear communication channel for updates and progress reports. Be available to answer questions and provide feedback as needed. Throughout the rewiring process, stay organized and keep track of all documents such as permits, contracts, and invoices. Also, take photos of the wiring before the walls are closed up, as this can be helpful for future reference or troubleshooting. After the rewiring is complete, thoroughly test the electrical system to ensure it is working properly. Use a multimeter to check the voltage and continuity of the circuits. Also, test all outlets, switches, and fixtures to make sure they are functioning correctly. If you find any problems, contact your electrician to fix them immediately. By following these steps and tips, you can successfully rewire your home while keeping costs down and ensuring a safe and reliable electrical system. Remember to prioritize safety, obtain permits, and hire a qualified electrician. Also, stay organized, communicate effectively, and thoroughly test the system after the rewiring is complete. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or building inspector for specific recommendations and requirements.